So in my last video I talked about how these circle theorems work, but what I didn't talk about is how to describe them according to the syllabus, because there are some words they like you to use, and they do actually ask you in the exams. They don't actually say describe these circle theorems. What they say usually, especially in EdXL, they love to say this famous phrase, well, famous to exam teacher, math teachers I suppose, give a reason. Yeah, that's like part B of a question. Part A is like do the circle theorem question, and then part B they say give a reason. What that means is describe one of the circle theorems you've used, and using the standard words they like you to use. You can get away with, not get away with, but you can use certain other words, and I'll talk about that as well as I go through these descriptions. So let's go through this one here. Angles in the same segment are equal. That's the description for this thing here. So what's a segment? A segment is a piece of a circle. So a piece of a circle where the piece is cut by a chord. So this is a chord, a straight line from one part of the circumference to the other. That's another chord there. So if this is the chord, then that would be a segment, and that would be a segment. Here's another chord, so that's a segment, and that's another segment. The stuff inside included. Anyway, so these two angles are in this massive segment separated by this dotted chord here. So it's a tiny chord there and a massive chord on the right. Yep. So these two angles are in the same segment, like it says. But it's a bit weird in that it didn't mention that, yes, they have to be in the same segment, but also the angles have to be touching circumference. So this description doesn't explain everything, but it seems that all the descriptions are a bit like that as well. So they kind of expect you to, or it kind of assumes that the angles are on the circumference or on the edge of the circle. Anyway, so that's that description. You could use your own words a little bit, yeah? So you could say something like, if you got two angles on the circumference, both subtended by the same points. Now, subtended just means kind of anchored down by the same 2 points would be a description. So this angle is anchored down, held down by these 2 points, if that makes sense. Or has its base at the same point. Subtended means like the base or anchored down, right? Anyway, so both these angles are anchored or subtended by the same 2 points. You've got to use that word, subtended. Can you see that there? Anyway, which we're going to use in the next rule anyway, so I'll be talking about that. So two angles at the circumference subtended by the same points are equal. I don't know if that's shorter or longer, but yeah. And if you really want to use that description I just said, but it's not written here, well, what you got to do... Oh, what just happened there? What you got to do is go to my book, and I've got the descriptions written on the same page as this thing. This is from my book, by the way, this example. Anyway, next thing we're going to do is describe this rule. The angle subtended by an arc at the center of a circle is twice the angle subtended at any point on the circumference. God, this is such a terrible description. God, but it's a standard syllabus description, so if you use it, you get the marks. Normally it's a 1-mark question anyway. Okay, and just so you know, I really don't like memorizing stuff, because that just gives you a headache and makes you nervous in the exam if you're just juggling all this stuff in your mind. If instead you understand stuff, okay, then you'll be better off in the exam. And what I'm saying is, maybe try to think of a description, which I've also got, all these descriptions I'm about to tell you that are not written here are all written in my book, yeah? So the description I would use alternatively, and wow, this is so much easier, and you get the marks for it because they've seen it in, what they call it, those mark schemes, yeah? All you have to say for this one is the angle at the center is twice the angle at the circumference. It's crazy. and that doesn't even really explain much, like that description, but you get the marks for it. Anyway, next one. So if you got this triangle business, the angle in a semicircle is a right angle. So there we go. It's a bit like that one, yeah. That yes, there's an angle in a semicircle, yeah, but where in the semicircle? We're assuming again that the angle is on the edge of the circle, at the circumference. Okay, so here's an angle and a semicircle, and it's a right angle, and that's a pretty good description. Yet again, I might still, it's kind of good to use your own words. Your own words might be, if you got a cyclic triangle. Maybe that's a bit of a crazy word, cyclic, for you, but cyclic just means it's a shape that has all its corners touching the edge of the circle. So here's a cyclic triangle with one side as a diameter. The angle at the circumference will be 90 degrees. To be honest, if you wrote that down, that would take quite a long time. So that's a nice one to go for, that description here. The angle in a semicircle is a right angle. It's not too hard to remember if you practice. Okay, this one's pretty easy, thankfully. Opposite angles in a cyclic quadrilateral sum to 180 or add to 180. Just say add to 180, it's easier, isn't it? So, yeah, what does that mean? I've already gone through the descriptions and how these circle theorems work, so I'm not really going into too much, but here's your quadrilateral four-sided shape, opposite angles, these two or these two opposite angles. Sum means add up to 180, so these two add up to 180. Okay, next one. A radius and a tangent meet at 90 degrees. That's too easy, right? I'm not even going to talk about that one. Tangents from an external point are equal in length. Gosh, that is one to change. Alright, I love how short that is, like a lot of these syllabus descriptions, but it really doesn't mean much. Okay, it really doesn't mean. I almost don't want to go into it. I'm just going to go into the alternative description, which is tangent. The distance between tangent. Oh gosh, how does it go again? The distance between where tangents meet a circle and where they meet each other are equal. Okay, so here's your tangents. Okay, the distance between where they meet the circle to where they meet each other. So these are the points where they meet the circle to where they meet each other are equal. Okay, so yeah, in my book, there's a rather than you memorizing that description, just read it off from my book. Yeah. Anyway, next, alternate segment theorem. I don't even need to say anything about that. That's brilliant. It's probably the hardest one to understand, but the easiest one to describe. You just say alternate segment theorem. That's it. That's good. It's the only rule with a name. And finally, the perpendicular from the center of a circle to a chord bisects a chord. Oh gosh, just saying something really easy but in a hard way. So just say it in your own words. Definitely this one. You say a line from a center to a chord bisects a chord if it meets at 90 degrees. Cool. So that's it really.